Okay, we will be recording. This is going to be on section out of 2.1 out of chapter 2 using ratios, percents, and proportions. But we are actually just going to do in this first recording the section 2.1, which is numerical ratios. So ratios are going to represent the relationship, of course, between two parts of a whole, or the relationship of one part to the whole. So ratios are written with a colon between the numbers, and of course they may be read as per, of, to, or in. So they could be written, it's showing you here, 1 to 2, or it could say 1 part to 2 parts, okay, or you can say 3 to 4, or that means 3 parts to 4 parts, same as 3/4. Okay, because they can use per, in, or of instead of to, depending on what type of mathematical problems that you are performing. And of course, another example, like 1 to 20 can be read as 1 part to 20 parts. And also it could be written 1 over 20. So just remember the term ratio is a numerical representation of the relationship between two parts of the whole or between one part and the whole. So a 1 to 100 concentration of a drug, of course, means there is one part of that drug in 100 parts of that solution. Okay. So on the next table, we have here some examples. So 250 milligrams to 1 tablet, or it could be written in the reverse, 1 tablet to 250 milligrams, or 1 gram to 100 milliliters, or 100 milliliters to 1 gram. Okay, or 500 milligrams to 20 milliliters, or 20 milliliters to 500 milligrams. So just to kind of go through and give you some examples out of your problem set that's in your book, and these are on, I'm taking them straight out of your book on page 37. Okay, so the first problem set, it says express the following ratios as fractions and reduce to the lowest terms. Okay, so this is on page 37, and I'm just going to write the numbers I'm using straight out of your book. Number 1, the ratio is 3 to 7. So if we wanted to convert that over to a fraction, you would put 3 as the top number, and we would use the colon as your line, and a 7 as your bottom number. Okay. And that one is actually already reduced down to its lowest terms already. If you look at number 2, okay, so you have 8 to 6 as your ratio. So I always put it in a fraction first. So 8 goes on top, 6 goes on the bottom. Okay, so first what you want to do is you want to reduce that down. So we know, is there a common number that will go in both of these? And we have, of course, 2 will go into 8. 2 is going to be our common number. It's going to go both in those numbers. 2 will go into 8 4 times. 2 will go into 6 3 times. So you have 4 over 3. So then what you would do is you would actually divide 3 into 4, and you'd come up with 1 1/3. That would be the lowest term. Next, I'm going to I'm going to skip down to number 4, because I'm just giving you a few examples to get you started. 4 to 6, again, 4 would be on the top, colon would be your line, 6 would go underneath. Okay, this can be reduced down further. 2 is a common number that will go in both of these evenly. So 2 will go into 4 2 times. 2 will go into 3 3 times. So your answer is 2/3. Okay. So those are some examples of the first section. Okay, the next problem set 6 through 10 is also on page 37 to give you some more examples. These we are going to have them in fractions. So number 6 is 2/3. And what we want to do is reduce the following fraction to the lowest terms and express it as a ratio. So remember, when we have our 2 on top, it's first. Our line, we're going to change back into a colon, and then 3. So if you're looking at this, you're just pretty much tilting it up in order this way, and you have 2-3. So that's how we're doing it. So your ratio answer was 2-3. Number 7, we have 6/8. Okay, but first, if you look at this, it needs to be reduced down. So 2 is a common number that will go in both of these. 2 will go into 6 3 times. 2 will go into 8 4 times. So it takes it to 3/4, and then you want to convert that over into a ratio, 3:4. Okay. So those are some examples off of page 37. Next, we're going to go through a discussion. This, of course, you have a 4:100 solute that has 4 grams of active ingredients in 100 milliliters of solution. How much active ingredient would there be in 500 milliliters of solution? Okay, now this section I haven't actually went over the rules yet of your ratio proportions, but I'm gonna go ahead, since it's in this section, I'm gonna go ahead and do it. They do it one way, and I have another way I like better. I'm going to show you both, and you can do which ones you prefer. Okay, so this one your answer is going to be 20 grams, but how did you get at that? Okay, what you want to do is when you want to work with a ratio and proportion, you always have to have 3 parts, and you're usually finding 1. Okay, so we're finding X grams. When you have a 4:100 solution, if it does not tell us what units to use, usually the smaller number in the front is going to be grams, and the one in the back is going to be milliliters. Okay. Sometimes it will tell us differently, but if it does not tell us differently, that's what we assume. Okay. So we know we have 4:100, and they told us that 4 is 4 grams, and that 100 is 100 milliliters. So they've just told us what it is. But see, we got to take this ratio, and we need to put it into a fraction. So that's what we have done here. 4 grams over 100 milliliters. So how much active ingredient would there be in 500 milliliters of solution? So we put the 500 milliliter solution down here on the bottom, and then we put the X grams on top. Why do we do that? We do that because when we're setting up a ratio and proportion question, you want like units on the bottom and like units on the top. Okay, if you do not have it, it will not work out. So milliliters on the bottom, on this side, milliliters will be on the bottom here. Grams at the top here, you must have grams are here. Okay, so what we do next is, I'll show you how they do it. They take it and they multiply 500 by each top. Okay, and that's how they come up with X gram equals 20 grams. Okay, on the next sheet here, I've got this same problem up, and I'm going to tell you how I do it. So I first start with my known 4 grams over 100 milliliters. 4 grams over 100 milliliters. Okay, I know I have it says of solution, how much active ingredient would there be in 500 milliliters of solution? Well, 500 milliliters, so where would I put it? Oh, we have milliliters down here. We would also need to put milliliters in here on this side, okay, at the bottom. And we know we're trying to find X of what? Grams, because it did not tell us, so we're going to assume it's grams. So what I do is I cross multiply. And I'll do it. Anything that you multiply the X by, so 100 times X, will always go on the bottom. Okay, 100X. 4 times 500 is going to be 2,000, and it's going to go on top. So now you just have a basic simple division one time. Okay, so you could take your calculator and go 2,000 divided by 100 is 20 grams. Or if you have a circle on the bottom, a zero on the bottom, you can mark it out on the top. Okay. If you have another zero on the bottom and you have one on the top, you can mark it out. Okay. So now you're left with 20 over 1, and 20 divided by 1 is 20. So that's just one way that you can divide without having to use your calculator. But you have to have the equal number of zeros on the bottom as you do on the top, and then once you run out of those equal numbers, you stop. Okay, so it'll be 20 grams. Next, we're going to look at your numerical ratios. If you look on this is going on page 36 in your book, it shows you the ratios on an ampule label. So the ratios are commonly used to express concentrations of a drug in solution. So this is showing you an example of 500 milligrams to 20 milliliters. Okay. So if you want to write that out in a ratio form, it would be 500 milligrams to 20 milliliters. If you wanted to take that into a division, you just raise them up. 500 milligrams, your colon as your line, and then your 20 milliliters goes on the bottom. So the ratio, of course, is indicating the total amount of drug in the ampule of the most important, is going to be the most important to the pharmacy technician as they're working with calculations. So now if we look at these practice labels here, this divan is coming out of your problem set, and it's number 11. Okay, all your problem set, and it says state the ratio for the following doses. So this one is a little bit tricky because it doesn't tell you milliliters because it's in tablet form. So if you have 40 milligrams, you're going to have 40 milligrams per one tablet. So you have 40 milligrams per one tablet. Or you can put it into a fraction, 40 milligrams over one tablet. Okay. So this problem set's kind of getting you to look at the drug labels on bottles and showing how you can put them in ratios. Okay, this one, their triliptyl, okay, if you wanted to put it, it's actually number 12. Okay, so this one's actually number 12 and 15 on page 38, but for right now, at the top here, I'll do number 12. Because number 12, you're wanting to state the ratio for the following doses. So you have 300 milligrams per 5 milliliters. So you have 300 milligrams to 5 milliliters. Or if you wanted to put it in a fraction, 300 milligrams to 5 milliliters. Okay. Now, if this same label, if you look at question number 15, it says you have, and I'll write it out here, 10 milliliters of your triliptyl suspension. I'm going to abbreviate that SUSP. Okay, which means you have 300 milligrams in 5 milliliters, which we've already determined that from question 12. So what we want to do here is we want to actually go in and solve. We have 3 parts, so we could do a ratio proportion and find what we need in the grams. So we know this is our known fraction, so we'll go ahead and set it up. So we have 300 milligrams per 5 milliliters. Okay, and then our third known is our 10 milliliters. So if we have 10 milliliters on the bottom here, we need to put milliliters on the bottom here, and we know our known is 10. So we need 10 milliliters of your triliptal suspension. So how many milligrams is that going to be? Okay, so what we're going to do is we're going to do our ratio proportion, and we're going to cross multiply because I like to do it my way. I think it's just the easiest, most simplest way. So 5 times x, anything that you multiply x by always goes on the bottom. So it'd be 5x. 300 times 10 would be 3,000. So 3,000 divided by 5 is going to be 600. So you're going to have 600 milligrams in 10 milliliters. Okay. Then our last problem set, this is actually number 20. Okay, so this one is asking you to fill in the blank, and I'm just going to read it. It says you have a 1 to 1,000 solution, and this is on page 38, number 20. 1 to 1,000 solution contains 1 gram of 1,000 milliliters. Because remember, I told you if it does not tell us grams or milliliters or any numbers, this is doing a different conversion, so we don't want to look at it. So 1, we would assume that is grams, so 1 gram to 1,000 milliliters. Okay. So then of the product, and 50 milliliters of that solution contains what? So if I had, we know our known is one known is 1 gram per 1,000 milliliters, and it's given us a third known of what if you have only 50 milliliters? How much of a gram is that? So then we're just going to set up our ratio proportion. We know our known is 1 gram over 1,000 milliliters, and we have 50 milliliters is our third known. So how many grams would we have out of 50 milliliters instead of 1,000? So then we're going to cross multiply. X times 1,000 always goes on the bottom because you're multiplying it by the x. And I always put an x with the number just to kind of remind you. So it would be 1,000. And then 50 times 1 would be 50. If you took your handy dandy calculator and took 50 and divided it by 1,000, it would come up to be 0.05 grams. So you have 0.05 grams in 50 milliliters. Okay. So if I was you, I would go through and do all of the problem set questions. Because with math, the more practice you have, the easier it gets. So go ahead. I did some of the questions out of your problem set on page 37 and 38. And go through there and work those out. And if you can't get an answer to one, if you just email me, I can help you work it out either by phone or on our online meeting room. So you can come by my office. I can help you work them out. Okay. But the answers to these questions are in your Appendix A. Okay, at the back of your book. So once you're working these problems out, you can check your answers to make sure that you're working them out correctly. If you have any questions, just give me a call. Thank you.